So this section is all about finding symmetry and talking about whether or not we have something a line of symmetry or a rotational symmetry. So we know in our bodies that we have a line of symmetry right down the midpoint of our bodies, and if we were to kind of look from left to right, we have things that are as similar on the left as they are on the right. That's like a line of symmetry. It's something that maps, symmetry is a motion that maps a figure onto itself. So we talk about a line of symmetry, it's like a line of reflection that if you were to fold the figure along that line or use a mirror, it would reflect the figure onto itself. That would be called a line of symmetry if you look at this example of the moon. Rotational symmetry is like this example here with a star, where if you take it and you were to turn it, it would be right back on itself. And depending on the number of lines of symmetry, that will help you find the angle of rotation. And as it's listed here, this is about 72 degrees. The angle of rotation will be a number that's somewhere between 0 and 180, but it can't be over that because then you'd be right back on itself. The angle of rotation will always be a fractional part of 360 because that would be a full circle. So you have to take the number of lines of symmetry and take 360 and divide it by that. So if we were to figure all this out, you would have, there's 72 degrees for each one of these. So then if you're going to go the angles of rotation, you could rotate at 72 degrees, or two of those, which is 144, or three of them, which is 216, and so on. So to kind of talk about how these are looking at, if we look at example A, we have this figure here. It's a four-sided shape. If we were to take and try to draw using a protractor, a line of symmetry, if we take and draw one from this point here all the way down to the other point, definitely a line of symmetry, because if we were to fold it along that pink line, it would map one side directly onto itself. So when you're thinking about lines of symmetry, that's kind of what you're thinking about. If you were to fold it along the lines, would it be directly the same figure? So then I want you to stop and think about it. What would be some other lines of symmetry? Well, one that seems pretty clear is this one right here. If we were to take and fold the top over the bottom, that would be another one. And if you take your paper and kind of turn it, you can see that if you were to draw this segment here, this is another line of symmetry. And in like manner, if we draw the one that's here, this would also be a line of symmetry. So one thing that would help you is if you were to use your patty paper and a copy of the figure, you'll be able to see that there are 1, 2, 3, 4 different lines of symmetry. So we have 4 lines of symmetry. Now it also has rotational symmetry, because if we were to take this figure here and rotate it, we would be able to get it directly back on itself. So if we take 360 degrees and we divide it by the number of lines of symmetry, 360 divided by 4 leaves us with 90 degrees. So this shape, if we take and rotate it 90 degrees, this point will be here, this one becomes here, and you can see that it directly maps onto itself. So this one has 90 degree rotational symmetry also. Now, not all figures will have rotational symmetry. Not all of them will even have a line of symmetry. So you have to stop and think about it and look to see if whether or not you can find those lines of symmetry. So let's look at the example B. Take and try to draw your lines of symmetry. It looks like I can take and draw one here. So now if I fold it over, it will be right on top of itself. And let's see, what are some other ones? Maybe if I draw, it looks like if this, I go directly down through the center of this other side, and then this other point. So with this shape, I have 3 lines of symmetry. I have 1, 2, three distinct lines of symmetry. So if I then take my three lines of symmetry and then take 360 divided by 3, that'll give me my rotational symmetry. So that means if I were to measure my angles here, I know that if I were to take and turn this figure 120 degrees, it would be back on itself. All right, so let's look at part C. Part C looks to be a four-sided figure. We have four right angles and each side is the same length, so we have a square. Can't spell square. So take a minute and try to find all the lines of symmetry of a square. I'm going to try to do mine, see what I get here. I know that I can go from diagonal to diagonal, so that's 1. I know that I could go from here to here, that's 2. I know that I can go from here to here, this is 3. And then from here to here, which is 4. I think that's all there is, and I try to find some other ones. So I have 4 lines of symmetry. So then I take 360 and divide by 4, because I think if I were to take this and turn it 90 degrees, I would be right back on the paper, which seems to be the right thing. So if I take 360 divided by 4, I get 90 degrees, and it's certainly true. If I were to take angle B and rotate it 90 degrees this way, it would be right on top of angle A. So if I take the whole shape and I rotate it 90 degrees, I will end up right back on top of itself. So it has 90-degree rotational symmetry. All right, so let's look at part D. Part D, we have a quadrilateral. It is, if you turn it, it looks to be a trapezoid, which means it has one set of parallel sides. We don't know anything else about it, though, other than we have 2 right angles. I don't see any lines of symmetry. Like, is there any way where we can draw a line that will make it so that when it will directly fold on top of itself? I'm not seeing anything. I don't think there are any lines of symmetry. So like I said before, a figure does not need to have a line of symmetry or even rotational symmetry. Alright, second to last example, we have, looks to be like an arrow, so to speak, lines of symmetry. Looks like there's one right here from cutting it right in half, right there. So there's a line of symmetry, and I don't see anything else. If we try to cut it here, it would cut E and F in half and I and H in half, but it would not make it so that when we folded it, it would be directly on itself. If this part of the figure wasn't there, then it certainly would, but because we have this part up here to worry about, this looks like this part here is the line of symmetry. And if you look at it this way, you can certainly see that that is the only line of symmetry. So we have one line of symmetry, and it doesn't look like there's any rotational, because even if I do 180 degrees, which seems like it might work, the arrow is pointing in the opposite direction. So there is no rotational symmetry. So we have one line of symmetry and no rotational symmetry. And last but not least, we have a 1, 2, 3, 4, 5-sided figure, which is a pentagon. We have that these angles all inside are the same, and all the side lengths are the same. So this is a regular pentagon. So to try to draw all the lines of symmetry of the pentagon, you think about it, let's see, looks like if I draw from here to here, I'd cut it directly in half. Same if I wrote to rotate it and draw a line from L directly in the center, and then one from N directly to its opposite side, and then P directly in its opposite side. And as I'm doing this, you can see as I'm rotating it, it certainly has rotational symmetry. So I have, how many lines of symmetry? I have 1, 2, 3, 4, 4 different lines of symmetry. Oops, I forgot one. Here through R, which makes it 5 lines of symmetry. So I have 5 lines of symmetry. And since we can turn it and make it so that the figure is directly on itself, it has rotational symmetry. So to figure that out, you take 360 divided by 5 because of our 5 lines of symmetry, and that leaves us with 72 degrees rotational symmetry. So for your homework, I recommend that you use a protractor, or at least some sort of straight edge so that you can draw your lines of symmetry, and if you want to, you could even try to measure your angles of rotation and see what that would be. It looks like to go from L to J, if I were to measure that, would be my 72 degrees that I calculated, and you can see that from here to here is about 72 degrees. So there's your angle of rotation. Good luck.